Hello, quick video on the laws of logs. We looked in previous videos at how logs work as a sort of inverse function of powers. So here we've got 2 to the power 3 equals 8. Yeah, we're all happy with that, aren't we? 2 times 2 times 2 equals 8. And we can write it another way, which is, or what power do we have to raise 2 to get 8? Answer 3. Yeah, and that was our formula for that. But we also know about power laws, don't we, from our other work? So if we had, let's have 2 to the 3 times 2 to the 4, well, we know that that would be 2 to the 7. Because we've learnt, haven't we, that we can add the 3 and the 4, and if we had 2 to the 4 divided by 2 to the 3, we would end up with 2 to the 1, wouldn't we? So there we subtracted the power, and I could write those here on the left. If I've got a base, here's our base is a here, so a to the x times a to the y equals a to the x plus y, and a to the x divided a to the y gives us a to the x minus y. And remember, the other thing, the final one here, is if I had 2 to the 3 and then I did that to the power 4, I'd get 2 to the 12, wouldn't I? Because I've got 2 to the 3 times 2 to the 3 times 2 to the 3 times 2 to the 3, yeah, and then I can expand the 2 to the 3s, or I can just add them, 3 plus 3 plus 3, there we go. So that's the final power law, that a to the x all to the power, so I've put that in a bracket to show that all to the power y is going to be a to the x times y there we go. So we can use this lot to work out the laws of logs, which we're going to have to use. Okay, let's use an example. 8 times 16 is 128. Yeah, we're all happy about that. Let's rewrite that as powers of 2. So 2 to the 3, that is 8 is 2 to the 3, 16 is 2 to the 4, so we know the answer is 2 to the 7. And therefore, if we were just considering the indices, because that's effectively what we've just done there, 3 plus 4 equals 7, yeah? But we know that writing in log terms, that 3 is log base 2 of 8, yeah? So let's just do that quite slowly. What power, that's what the log bit means, what power must we raise 2 to get 8? Answer 3. So these two are equivalent, yeah? And we know that log 2 base 2 or 16 is 4, yeah? What power do we have to raise 2 to get 16? Answer 4. We happy with that? And on the right hand side of this expression we have 7. Now we've already shown, we know that we started with 8 times 16, and we know that we're looking here for the powers. So what power do we have to raise 2 to get 8 times 16? That's exactly the same, isn't it? That's 7. So if we now substituted, rather than 2 we just had an a, because that really wasn't, we could do that throughout, because this could have been all powers of 3, this could have all been powers of 4, it still worked, wouldn't it? So we can generalize that to the base being a, and then if I put in place of this first value here, I'm going to put the number x, and in place of the 16 I'm going to put the number y. Then we can see that this, inside this bracket, is x times y, which we write algebraic as xy. Yeah. So using that example that we've just looked at, we can see that we've got a generalized first law of multiplication of logs, in that the log of x times y is just going to be the log of x plus the log of y in any base. Let's consider division. So 16 divided by 8 equals 2. We're all happy campers on that. 16 is 2 to the 4 and 8 is 2 to the 3. So we know that implicitly what we can do in our head is take away the powers to get 2 to the 1. Yeah. So what we've done at the index level, at the power level, is we've worked out 4 minus 3 equals 1. Happy with that? Of course, we know, and we looked at it slightly earlier, that the number 4 can also be written as the log base 2 of 16, because we know that the log base 2 of 16 is 4. Let's read that again. What power do we have to raise 2 to get 16? Answer 4. And here for our 3, we've got what power do we have to raise 2 to get 8? Answer 3, because 2 to the 3 is 8. And finally, on the right hand side, what power do we have to raise 2 to get 2? Well, the answer to that is 1. There we are. So just following through what we did before, we've got our 16 here. So that if we call, again, if we use the 2 could be any number, couldn't it? Any base we could do this in. We could do this in powers of 3. It could all be powers of 3, 4, 5, etc. And if we replace the 16 with an x, we call that x, and the 8 we call that y. Well, we know over here we've got 2, which is x over y, isn't it? So we've just proved in principle the concept, or we've seen an example rather, of this second. This is the log law of division. Yeah, that at any base a, log of x minus log of y is the same as the log equivalent to log of x divided by y. And finally, let's have a final log powers of law around powers. So let's have a look at the example 8 times 8 times 8 times 8, which we know, we're quite happy, aren't we? That's 8 to the 24. Okay, let's rewrite that in powers of 2. So 8 is 2 to the 3. Yeah, so it's 2 to the 3, 2 to the 3, 2 to the 3 on the left hand side. And on the right, we could rewrite it as 2 to the 8 is 2 to the 3. And that's all to the power 4, isn't it? And if we used, just looked at the indices and what we would do to confirm that, we're happy that that's 3 plus 3 plus 3 plus 3. And on the right hand side, we know from our law of powers here, power law, that 2 to the 3 to the 4 is actually 2 to the 12, isn't it? Because that's 3 times 4, yeah. So here's our 3 times 4. Now we know that if we're looking back at the 3's now, each one of those is equivalent to the log base 2 of 8, isn't it? Because, let's read it again. What power do I have to raise 2 to get 8? Answer 3. Yeah, so we can write that 4 times. So we're absolutely clear that on the left-hand side here, that's equivalent to 4 times the log of 8 to base 2. Yeah, and we know on the right-hand side that this 12, 2 to the 12, that we've got on the right-hand side is this log here. Reading it, what power do we have to raise 2 to get 8 to the 4, which we also know is 2 to the 12, isn't it? Okay, so if I now just say, well, I could do this as many times as I like, so that's going to be our value n, because I could add and multiply by another 8, couldn't I? And then I'd get 3 plus 3 plus 3 plus 3 plus another 3. And on the right hand side, I'd have 3 times 5, wouldn't I? I'd have 8 to the 5. Yeah, so I'm going to use that as n. So if n is 4, then I know that I've got 4 times this log on this side. And on the right hand side, I know that I've actually got 8 to the power n. Yeah. So we've just proved a generalized, we've given an example rather than a proof of our generalized position that n times the log of a to the x, so base a of the number x, then we know that that is a log base a of x to the n. And if you think about it, It's easy enough because in here we've basically just got, haven't we? We've got log a of x times x times x times x times however many times through the n, haven't we? And we can replace, excuse me, we can replace each one of these with a separate log, can't we? Because all logs added together, we could just replace that, can't we, with log a of x. Because it's multiplication, then we can just treat that as addition, can't we, of the logs. And multiplication inside becomes addition outside, doesn't it? So there we are. So there are 3 laws of logs, and here's my quick summary for you to look at. I hope that's for you.